Good afternoon, I'm Roja. Now I'm going to explain one of the important topic in data structures, that is trees. Trees. Tree is a non-linear data structure and it is a collection of nodes connecting with the links. Tree is a non-linear data structure connecting non-linear data structures and it is a collection of nodes connecting with the links. Connecting with the links. This is the definition of trees. So here I am taking simple example of trees. So this is a tree diagram. So in this, these are the nodes. These all are the nodes. And these we called as edges. Edges are nothing but links between the nodes. Links between the nodes. In a tree diagram, first node we called it as root node. In every tree diagram, first node we called it as root node. That means it does not have any parent node. Which node does not have any parent node? We called it as root node. And next is parent node. So for example, C is the parent node. Parent node means which node having one or two children. One or two children we called it as parent node. And leaf node. Leaf node. Leaf node is nothing but which node does not have any child nodes. That's called as leaf nodes. In general, in every tree diagram, the last nodes are called as leaf nodes, and also we called these nodes are external nodes. External nodes. And next terminology word is internal nodes. Internal nodes or non-leaf nodes. So non-leaf nodes means the node in a tree which contains a child node. Which contains a child node. That nodes are called internal nodes or non-leaf nodes. And next is degree. Next is degree. Degree means a node contains child nodes. Child nodes. Node contains how many child nodes? So for example, here degree of the B. What is the degree of the B? So here degree of the B is 2. Degree of the B is 2. So because B having 2 child nodes here, and then degree of C is 2. C also having here 2 child nodes. C also having here 2 child nodes. So this is the degree of the C. Next is the level. Next is the level. In each and every tree, first root node at 0 level. Root node at 0 level, and next child levels are child levels are 1, 2, 3 and so on. For example, the level of the A is 0 and next level is 1, next level is 2. Next, height of the tree. How we calculate this height of the tree? Height of the tree means the total number of edges from leaf node to root node. Leaf node to root node. So, how many edges are there in between leaf node to root node? Leaf node is nothing but the last node of the tree. The last node of the tree, and root node is the first node of the tree. So, we calculate the height of the tree. So, A to B, 1 edge, and B to D, 1 edge. So, height of this tree is 2. Height of this tree is 2. So, these are the terminology words of the tree diagram. Next, we will discuss types of the trees. Types of the trees. There are total number of trees are 4 types. First one is general trees. Second one is binary trees. Third one is binary search trees, and fourth one is AVL trees. So, first one, let us take first one. General trees. In general trees, the node contains n number of nodes. The node in general trees, tree may contain, in tree, each and every node may contain n number of nodes. In tree, each node may contain n number of nodes. For example, here I am taking example of general trees, and A as the root node here, and A having 3 child nodes, again B having 2, so B having 2 child nodes, and C having 3 child nodes, and D having J 1 child node. So this is the general tree diagram. General tree means in a tree, each and every node, it may contain any number of nodes. So that is called as general tree. And next is binary trees. In binary trees, in a tree, each and every node contains at most two children. Each node contain at most two children. At most two children means it should contain the maximum number of two children only, not more than two children. For example, A, B, C and D, E, F. At most two children means the node, it may contain 0 also okay, 1 also okay and 2 also okay. But it should not more than 2 nodes. So here A having 2 child nodes, B having here D and E 2 child nodes and C having 1 child nodes. So this is a binary tree. So for example, if I add two more child nodes here, it is not a binary tree. So that in a tree, each and every node must and should contain at most two children, 0, 1 or 2, not more than two child nodes. So this is the binary tree. And next is binary search trees. In binary search trees also, each and every node in a tree contain maximum two children, same as binary tree. In binary search tree also, each and every node in a tree contain maximum two children, and that is also, it may contain 0, 1 and 2, but it should not more than two child nodes. So the difference between binary tree and binary search tree is, in binary search tree, when we are inserting the values into binary search tree, we should follow two statements. That is, first one is, in a tree, the left subtree node values should be less than root value. This is the first statement. So in a tree, the left subtree node value should be less than root value. And second statement is, in a tree, the right side, the right subtree node values should be greater than greater than root value. So in binary search tree, the values we are inserting numerical values. So for example, here I am taking 10, 5, 7, 20 and 25. So I am taking here example, these are the value. So I am going to insert these values into binary search tree. So before going to insert these values, so we should follow these two statements. So in a example, first value we consider it as root value. The first value we consider it as root value. So here I am taking 10 as root value. 10 as root value. Next, the left subtree node values. What is the left subtree and right subtrees? So for example, this is a tree. So this is a tree. This is the root node. So for this root node, left side part we called it as left subtree, and right side of this root node we called it as right subtree. And this is a node or entity which is used to store the data. This is an entity used to store the data. So according these two statements, first in example, first value here I am consider as root node, and next value is 5. So next value 5 compare with this 10. In a tree, left subtree node values should be less than root node. So first we have to compare this value with root value. 5 is less than 10. 5 is less than 10. So it should come under the left subtree part. So in left side 5 will be placed, and next value is 7. Compare this 7 with root value. What is our root value? Root value is 10. 7 is less than 10. Less than means come to the left part of the tree. So if the value is less than root value, directly come to the left part, first step. So in that left part, value is there, 5 is there. Already 5 is there. Then again we need to compare this value with 5 also. So 7 is greater than 5. If less than means left side. If it is greater than means right side of the root node. So root node it is less than. Okay, we'll come to the left part. Again we have to compare with this value also. So 5 is less than 7. Then so we should write that 7 as right of this 5. Right side of this 5. And next value is 20. So take the 20 and first step compare with this root value. 20 is greater than 10. If the value is greater than root node, directly come to the right side part. Right side of the root node. So right side no element is there. Right side no element is there, so directly we put this 20 as right side. Okay, next 25. 25 next again 25 compare with 10 first. Compare first 25 with our root value. 25 is greater than 10. Then directly come to the right part. Right part already we have 20. And again we need to compare that 25 with 20. 25 is greater than 20. So we need to place that 25 at right of the 20, not left of the 20. If the value is, for example, 19. If 19 is there means it is greater than 10, come to the right part. Again compare with 20. 19 is less than 20. So we need to place this 19 at left of the 20. So here 25 is greater than 20. So we should place the 25 value with right side of the 20. Right side of the 20. So this is the binary search trees. And next is AVL trees. AVL trees. AVL tree is invented by George Adelson, Wesley, and Landis. These three members are invented this AVL trees diagram. So what is mean by AVL tree diagram? The AVL tree is self-balanced tree. Self-balanced tree. So what is mean by self-balanced tree here and tree here? So in a tree diagram, each and every node follows the balance factor. Each and every node follows the balance factors. Balance factors, and that balance factors that balance factors either 0, 1 or -1 only. The balance factors 0, -1 and -1 only. In a tree diagram, each and every node follows the balance factor. So for example, here I am taking so this is a small example, this is a small tree diagram of AVL trees. So how we can calculate the balance factors of each node? That means the how many nodes that parent node contains. If it contains left subtree, right subtree, then always it should be 0. And last nodes also 0. So how means, for example, here I am taking the D. So what is the balance factor of D here? D having any left child? No left child. Any right child? No right child. So 0. And also see, there is no left child, no right child. 0. And next is D having any left and right child? No left and right child. So the balance factor of D is also 0. So for example, what is the balance factor of B here? So the B having left child 1, left child 1 minus right child. How many right child are there for B? Only one right child. Minus 1. 1 minus 1, 0. The balance factor of B is 0. And next C. So left child is there for C? No. So 0. Minus. So right child is there? Yes, right child is there for C. So how many right child? One right child. Right? 0 minus 1 equals to minus 1. So the balance factor of C is here minus 1. Next, what is the balance factor of A here? So how many left child nodes it's having? 1 and 2. 2 minus, and how many right childs are there here? 1 and 2. 2. 2 minus 2, 0. So the balance factor of A is 0. So the balance factor should always either 0, 1 or minus 1. So this is about AVL trees. Next I am going to explain the one of the most important topic in trees concept, that is binary tree. Binary tree traversal techniques. This is very important topic in trees concept. So traversal, what is mean by traversal? Traversal means visit each and every node in a tree exactly at one in a time, or visit all the nodes, visit all the nodes in a tree exactly one in a time. Visit all the nodes in a tree exactly one in a time. So there are three types of binary tree traversal techniques. There are three types of binary tree traversal techniques. First one is pre-order, pre-order traversal techniques. Second one is in-order traversal techniques. And third one is post-order traversal techniques. So these three are the binary tree traversal techniques. So let's understand one by one. So what is the pre-order traversal techniques? So first one is pre-order traversal techniques. First we write down the algorithm steps for pre-order traversal techniques. So based on those algorithm steps, we follow the and we apply that pre-order traversal technique on that tree diagram. So first step is visit root node, and next is traversing left subtree of node in pre-order technique. In pre-order technique. And third one is traversing right subtree of node in pre-order techniques. So what is the meaning of these three steps here? So for example, here I am taking one simple tree diagram. Here I am taking simple tree diagram. So what is the first step here? What is the first step? Visit root node. First we have to visit the root node of the tree diagram. And next, what is the next step here? Traversing left subtree of node in pre-order. So in left, come to the left subtree, and on each and every node we have to apply that pre-order techniques again and again. And next, after completion of this left subtree part, then traverse the right subtree of node and apply the pre-order techniques. So that means, for example, first visit the root node. So this is for remembering purpose. So first to visit the root node, and next is traversing left subtree, and next is traversing right subtree, So these three steps we have to apply each and every node in a tree diagram. Okay, so first we have to apply on root node, NLR. So here first visit root node. Any root node is there? Yes, root node is there. What is the root node? A. Next node is completed. So next is left subtree, traversing left subtree. Left subtree, come to the left part. So again we have to apply pre-order traversing techniques, NLR. So N is there, node is there? Yes, node is there. Next B. Next L. L is there? Yes, L is there. Again come to NLR. Okay, and node is there in first is what? N. N is D. So next, any L is there here? No. R is there? No. So this complete part of L of this B is completed. Okay, next R. R is there for B? Yes, R is there. Next come to the R part, and node is there? Yes, node is there. E. And L is there? No, L not there. And R also not there. So this complete right part also completed of this B. Okay. And this complete left part of A is completed. So complete left part of A is completed. Next, any R is there for A? Yes, R is there. Come to the right part. Again you have to apply NLR technique. So node is there? Yes, node is there. C. L is there? Not. No, L is not there. R is there? R also not there. Okay. So this complete R part also completed of this A. So this is the pre-order technique value. Okay. And next is same as in order. In order also So in order, first traverse left subtree, traverse left subtree of node in order, okay, and next is visit root node, and next traverse right subtree, of node in order. Okay, these three are the algorithm steps for in order. Here I am taking the same example. So in order, what are the three steps here? First, traverse the left subtree L, okay, next visit the root node N, and next traverse the right subtree L, N and R. So we have to apply these three steps on each and every node in a tree diagram. A, B, D, D. So here I am applying each and every node, the three steps L, N, R. So first L is there, yes, L is there. Come to the L part, L, N, R. Next, again you have to apply here also same three steps. L is there, yes, L is there. Next, N is there for this node? No. L also, L not there. Any L is there, left node is there? No left node. But node is there? Yes, node is there. L is not there, node is there. What is the node? D. And next R is there? No R. So complete node part is completed for this node. Next, come to the, so left part is completed. So left part of B is completely completed, right? So here I am tick mark. So next is what? Node is there? Yes, node is there. This is the node B. Next, R is there? Yes, R is there. This is the R part of B. Again we have to apply LNR technique on this also. Left is there? No left. Node is there? Yes, node E. Next, R is there? No R. So complete right part of this B also completed. So completely this left part of A is completed. Next, N is there? Yes, this is N. Next, R. R is there? Yes, R. Next we have to apply same these three steps on this node. L is there? No L. Node is there? Yes, node is there. R is there? No R. So complete right part of the node also completed. So last one is post order. In post order, the first step is traverse right subtree of node in post order. Next, traverse left subtree of node in post order. Next, third one is visit root node in post order. Next, third one is visit root node in post order. Next, third one is visit root node in post order. Next, third one is visit root node in post order. Next, third one is visit root node in post order. Next, third one is visit root node in post order. Next, third one is visit root node. So same as previous examples, we have to apply these three algorithm steps on each and every node of a tree. So here I am taking same example. So according to these three steps, so first visit the right, next left, next L. So we have to apply R, L and N. So first visit the right part of this node. Again we have to apply same three steps. So any R is there? No R. L is there? No. Node is there? Yes. Node is C. Next, complete right part of this A is completed. First we have to apply on root node. So first step is right traversing. So here I am taking right traversing. Again on this C also we have to apply these algorithm three steps. So right is not there, left is not there, only node is there. So here I am taking node and complete right part of A also completed. So next is L. Come to the left part. RLN. So right is there. Yes, right is there. And again we have to apply this technique, post order technique. Right is there for D? No. Left is there for D? No. Node is there? Yes. Node is there. So complete left part of this B is also completed. So sorry. Sorry. The first step is R. R means traversing right side. So right of the B is E. So first we have to apply this post order on right part of the B. So R is there for E? No. So right part, right is there? No right, no left. Only node is there. And next, so complete right part of B is completed. Next, left is there for B? Yes, left is there. We have to apply again on this node that post order techniques. So right is there for D? No right. Left is there? No. So only node is there. What is the node here? D. So left part of B also completed. Next, what is the last step? Node. Visit the node. Node. What is the node here? B. So complete right part also completed here. Complete left part also completed. So what is the last step here? N. N is there? Yes. What is the N? A. So this is the post order technique, and these three are the binary tree techniques. Okay, this is my this is the session about trees. Thank you.